After defining the problem, detailed specification of inputs acceptable by the system solution. That is called as defining the problem. From where I should start solving the problem. That is nothing but the initial state of the agent. Deterministic. Whatever the steps we are taking from moving one node to the other node, it should be deterministic. It should be predefined. Hello everyone, welcome to the session on Artificial Intelligence and Application for 6th semester B.Ca students. In this session, we are going to discuss about Unit 2. Myself, Induje, Faculty of Computer Science Department, Vidhyaashram First Grade College, the Temple of Excellence, Mysuru. Let us start what is there in Unit 2. We are discussing about problem solving by searching. Okay, so what all we are going to discuss, what all the types of problem solving agents, how to describe the problem solving agent, what is well defined problem, and what all the different searching techniques we have to solve the given problem. That all we are going to discuss in the Unit 2. As we are moving with the session 1, we will go with the what is problem solving agents. You know what is agent? Agent is an entity that acts on an environment, and when it comes to the problem solving agent, the problem solving domain which breaks the large storage problem into the small storage area and resolve one by one. As we are doing it the divide and conquer method, we are dividing the large problem into the smaller problem and getting a solution for the smaller problem and combining those solutions to get the solution for the larger problem. That is nothing but the basic concept what we are using in the problem solvings. The final integrated action will be the desired outcome. After combining all the small outcomes, final outcome will be the desired outcome what we are expecting from that particular problem solution. The problem solving agents in the artificial intelligence are the entity designed to find the solution to the problem by considering the various possible action and their outcome. Means we have to design a problem solving agents depends on the problem what we are solving by considering the various action that what we have to take to solve that particular problem. Depending on that, we are designing one agent. Those agents are called problem solving agents. Then we can also say that the problem solving agent is a result driven agent. So what is our main goal here? Main goal is to get the result for that particular problem, get the solution for that particular problem. So we can use a goal based agents here, right? To solve any kind of the problem, we can use goal based agent as it is a result driven. So we have to concentrate more on the solution, how to get the solution. So always focuses on the satisfying the goals. So we are using a goal based agents to solve any type of problem. Then in the problem solving agents, what we have is three basic types of problem what we have. One is ignorable problem, one recoverable problem, and irrecoverable problem. So when we are solving the problem, some steps can be ignored. Such type of problems are called as ignorable problem, in which the solution steps can be ignored. We have constructed one solution for the particular problems. If some steps is ignored in that particular solution, that does not affect the solution much. That is called as ignorable problem. Then reversible problem. For the reversible problem, when we are designed some steps to achieve the goal or the solution, that can be reversed. We can undo the procedure. For example, if I am moving from node A to node B by using node C or node D. Right. So once I'll move to the node C, then I'll move to the node B. I found that this is not the optimal solution. So what I can reverse back. I can come back to the starting position. I can go to node D and I can reach to node B. Either the way is possible. We can reverse, we can undo the steps what we have described. That is called as reversible solutions for the problem. And irreversible problem, in the solution steps you cannot undo. That is called as irreversible problem. You cannot undo whatever the steps you have taken. With that step only you have to go forward to reach the goal. That is called as irreversible problems. To give you the real life example, I can take the road, right? If you have a U-turn, that is called as reversible. You can undo, you can come back again to the position what you have missed for. In irreversible, you don't have U-turn, you have to go straight and you have to take another path to reach the goal. That is called as irreversible problem. These are some of types of problems what we have. Then steps for solving the problem. How we can solve the particular problem or the given problem. There are quite 5 steps what we have to follow to solve any of the problem. One is the problem definition. First, we need to know what is the problem exactly. We should define the problem properly. We should understand the problem, then only we can find the solution for that, right? So similarly, here also we should define the problem properly. What all the aspects are there, including those aspects, we should define the problem. Then after defining the problem, detailed specification of inputs acceptable by the system solution. That is called as defining the problem. We should analyze the problem. Once we have defined the problem, we have one problem, we know what is the problem exactly is. Now we have to analyze the problem. What do you mean by analyze? What all the possible ways I can do, or what all the resources I want to solve this particular problem. So that is nothing but the analysis. Analyze the problem thoroughly. What happens if this is a solution? If I do like this, what would be the outcome of this? Or I have a plan B. If does not work, I'll go with the plan B. So you have to analyze the problem, what all the possible outcomes you can get and what all the resources you need to solve that particular problem. That comes under the problem analysis. Knowledge representation. You should have a prior knowledge. Whatever the knowledge you have, you should able to make that use of that knowledge in solving the problem. Collect detailed information about the problem and define all the possible techniques. We should define all the possible techniques, depends on the prior knowledge whatever the agent is having. So that is called as knowledge representation. What would be the outcome of if step 1? What is the outcome of step 1? If the outcome of step 1 is this, can I give that as an input for the step 2? That all comes under the knowledge representation. And the fourth point is problem solving. Once we have defined the problem, we have analyzed the problem, when we have collected all the data related to the problem and all the resources that is required to solve the problem, then we are moving to solve the problem. Selection of the best technique. What all the technique we can use, that has been described in the previous step. In out of these techniques, which technique is to be selected to give the optimal result, that will be used as a problem solving technique. Select the particular problem, particular solution for the problem. So here it goes as defining the problem. First we should define what the problem is exactly, then analyze that particular problem, what is there inside that particular problem, what all the resources you need to solve the problem, then identify the solution, what all the possible solutions you can get if you utilize these resources for this particular problem, what all the possible solution you are going to get. Out of this possible solution, choose the best solution. Out of this possible solution, there are multiple solutions for the single problem. You have to choose the best solution out of it, and after that choosing the best solution, you need to implement that solution to get the goal or to reach the goal of the problem or to find the solution for the given problem. These are what all the steps we have in solving the problem. Next we'll move on to the well-defined problem and solution. As we have discussed what is problem solving agent, what is problem and what all the steps to solve the problem. Now we are moving with the well-defined problems and the solution. What is well-defined problem? If the problem is defined properly, as a first step we say define problem definition. Problem is defined properly, that is called as well-defined problem. Problem solution are clear, unambiguous problems with the precisely specified goal and solution. If I give the value 3 plus 2, I know what is the precise value, that is 5. We should define a problem such that there should not be an ambiguity. If I give plus or minus, it will be the ambiguity, right? So you don't know whether you have to go for addition or whether you have to go for subtraction. Similarly, there should not be such ambiguity in well-defined problem, and it should have a clear goal where we have to reach. We should have a clear goal in the well-defined problem. These type of the problems are particularly suitable for computational approaches, especially in artificial intelligence. When we are defining the problem clearly and when we know what is the goal or what is the solution precisely what we have to get, at that time we are going to use this type of well-defined problems in artificial intelligence. What is well-defined problem and solution? The problem can be defined formally in 5 components. How we are going to define this well-defined problem? Only the problem we are defining in 5 steps. First, what we have to check? Initial state that the agent should start. From where I should start solving the problem. That is nothing but the initial state of the agent. Then description of the possible action available to the agent. What all the, we have defined some behavior and the rules, protocols for the agent. Depending on that, he should describe what all the possible actions the agent can take. And then description of what each action does. If I do the action A, what would be the outcome? If I do the action B, what would be the outcome? Right. So, we have to describe what each action does. Okay. Then the state space from the directed network to the graph in which the nodes are states and the links between the nodes are action. So, how we are representing that? We are representing in the form of nodes or in the form of graph or in the form of tree, like this. Okay. So, we have to provide one state space. State space is nothing but number of nodes connected to each other in the form of network that can be represented in the form of graph or that can be represented in the form of tree data structures. Graph which the nodes are stated and the link between the nodes are action. These particular nodes are called state and the link what we are providing is called as action. Means agent is currently in the state A, he want to reach to the state D, what action he is supposed to take? If he want to reach to the state C, what action he is supposed to take? Here he can go to directly from A to D, or he can go to A to C, from C to D, or he can go to B, from B to C, then C to D. So there are 3 different possible actions, possible ways of solving the problem, right? So that description of what action each does and what will be the, we are reaching the solution or not. That's what we are describing the well-defined problems. Then the key characters in the well-defined problems are, one is clarity. As we have initially stated, when we are stating the well-defined problem, it should be clear and unambiguous. Whatever the problem statement we are giving, that should be very clear. Well-defined problem have a clearly stated goals, initial states and the possible action. From one reaching from start state to the goal state, it should have a particular action which is stated clearly. And then observable states. What are the observable states? What are the intermediate states what we have from the start state to the goal state? Those are called as observable states. The states of the problem is fully observed. We are working on which environment? We are working on fully observed environment. The agent can precise and accurately determine the current state of the system at any point in state. What is the current state? Where exactly the agent is and how far agent is from the goal. So that will be stated by using the observable states. Next key component what we have is deterministic. Whatever the steps we are taking from moving one node to the other node, it should be deterministic. It should be predefined. The outcome of the actions are predictable and deterministic. We should say, as we have given the example, from moving A to D, I have 3 different ways, right? C and B. So It should be determined properly. There should be predicted. We can move from node A to D. That should be predictable. Means we should predict the solution. Known action. We should go with the one more key component, that is known action. The set of possible action that can agent take is well known and clearly defined. It should be known, because here we know that A is connected to B, A is connected to C, and A is connected to D. In turn, B is connected to C and C is connected to D. We know that. We already know the action, what happens if I move from A to B. We have to move from A to C to reach the final goal. So that is known as well-defined action. That is, we should know the action, what is going to be happen. And next point is in key concept is defining the transition model. How it is transiting from one state to the other state. That is nothing but transition model. The transition model describe how the environment respond to the action is explicitly known. It should be known priorly how environment on which agent is working, how it is transmitting from one state to the other state or traversing from one state to the other state. That should be previously known, explicitly known. It specifies the possible states resulting from each action in each state. It will give the all the possible ways of reaching the final goals. A single goal. Well-defined problem should have only one goal. It should not have a multiple goal. If I am reaching from node A to D, it should be I am reaching only to the node D. Node G will not be the goal state. What is my goal state? D will be the goal state. Should have a single goal, well-defined goal that the agent aims to achieve. The success or failure of the agent is unambiguously determined by reaching or not reaching the goal state. If I am reaching the node D, then it is successful and it is determined. If I am not reaching, it is also determined and saying it is not reaching to the goal state. Then no uncertainty. There should not be any uncertainty when we define a problem using a well-defined statement. There should not be no uncertainty or randomness. Problem. The agent has a complete information about the environment and what is working on and what all the consequences of action is going to take. That's what we said. It works on what? Fully observed environment. It works on fully observed environment. Hence, agent has a knowledge of environment and what all the outcome of that environment for particular action. That should be known. A well-defined problem and the solution set the stage for effective problem solving. Why we are using well-defined problem and solution? For the effective problem solving, which provides the clarity, specificity, measurability and relevance, flexibility and practicality. This all can be achieved using the well-defined problem and the solution. It also provides the clear communication and understanding among the stakeholders and crucially in ensuring that the problem and its solutions are well defined. Once we have defined the problem properly, it's very easy to reach the problem and it will provide the good communication between the stakeholders who is working on that particular problems. Then well-defined solution. We have discussed about well-defined problem. Then what we have is well-defined solution that directly addresses identified problem and aligns with the established criteria and constraint. We know the problem is well-defined. How we get the well-defined solution for that? By addressing the particular problem. The solution should provide a clear path to resolve the problem and achieve the goal, desired goal. We should have a clear path. We should be very clear when we are choosing the solution. We have a multiple solution. We have to choose one particular or optimal solution. While choosing the solution, we should know it should have a clear path for achieving the desired outcome. And the key characteristics of well-defined solution is relevance. What I am getting, the output or the outcome, that should be relevant to the problem what we have defined. That is called as relevance. The solution should directly addresses the root cause of the problem and contribute to the achieving the desired goal. Whatever the expected result or the solution is there, that should be relevant to the problem what we have defined. If I say 3 plus 5 is equal to 8, that is solution is known, right? That is relevance. What we are doing the addition operation for the problem, right? That is solution. What we got is relevance. So if I say 3 minus 5 is equal to 8, 8 is a solution what I am getting, but it is not relevant to the action what I am doing, or not relevant to the problem what we have defined, because we have defined the subtraction here. So that not be the output, that not be considered as an outcome of the problem. So hope you understood what is a relevance. And next what we have is feasibility. What is feasibility? It should have a flexibility to change or opt the solution. The solution should be practical and achievable within the constraint of available resources such as time, budget and expertise. Within these characteristics or within these constraints, we should achieve the solution, we should achieve the goal. That is called as feasibility. Whatever we have, within that only we can reach the goal. That is called as feasibility. Effectiveness. The solution should be capable of resolving the problem and producing the intended result. It should be capable of resolving the problem. It should not go into some infinite loop, or should not go into some false outcome. So that is called as effectiveness. Scalability means you can scale the solution. If applicable, the solution should be scalable to accommodate the future growth. So for example, if I am reaching from node A to B, within 1 minute. So within 1 minute, but the solution should be such that we can reduce this time. We can reduce this 1 minute time and we can make it as 50 milliseconds. So that is nothing but scalable. Whatever the solution we are getting, it always be there is a future scope for that, changing that solution or improving the solution. Then implementation plan. When you have a perfect problem definition, when you have know what should be the solution, that implementation plan should be specific and very clear. Well-defined solution includes a clear plan for implementation, outlining the steps, what all the steps we have to take, in how much time each step has to be executed, that is timeline, and the what is the responsibility of the each node, what you are carrying, intermediate nodes, what are the responsibility of the each node, that all should be planned perfectly during the implementation time. So these are all the key concepts what we have for the well-defined solution. Search problem. What is a search problem? So whatever the problem we are defining and whatever the solution we are getting, how we are getting the solution. So we are getting the solution using some of search algorithm. We'll discuss what are the different type of search algorithm. First, let us see what is search problem. Search problem consists of state space, start state and goal state. This is my start state. This is my goal state. So I have to reach from start state to goal state, and whatever the space that comes here, this is called as state space. What is S? S is a start state. This is stop state, or we can say it as goal state. Right, and whatever the steps or the action we are taking to reach from S to G, that will be called as state space. 3, 4, 5, 7 and goal. So whatever this is there, no, that is called as state space. State space, the set of all possible states where you can be. You means agent can be. So these are all space the agent can reach. That is called as state space. Start state, the start states from where the search begins. So this is a start state from where search begins. So that is called as start state. Goal state or the final state, the function that looks at the current state, returns whether or not it is a goal state or not. This is a goal state, whether we are reaching to the goal or finding the optimal solution or not. That is called as goal state. Okay, then the solution to the search problem is a sequence of action called plan. What we have a solution, how to get the solution, how to reach from state S to state G by sequence of action. What is the sequence of the action? Yes, moves to the state 3, from state 3 it moves to the state 5, from state 5 it is moving to the state 7, from state 7 it is moving to the goal state. This is what called steps. So these solutions can be a sequence of steps called as plan, or sequence of action we can say called as plan, transfer the start state to the goal state. This plan is achieved through the search algorithm. How we are achieving this plan? Using the search algorithms. There are different types of search algorithm. So basically we categorize the search algorithm. One is uninformed search algorithm or informed search algorithm. Uninformed search algorithm is also called as blind search algorithm. Why it is blind search algorithm? Because the information we don't have what is a goal. We don't have any information about the problem or to the goal. That is called as uninformed. As name itself indicates, this algorithm doesn't require any information to reach the goal. It acts on the current situation. Where in the informed search, it has to have a prior knowledge, information about the goal state, how to reach the goal state. That is called as information search, or we can call it as heuristic search. So what all the algorithms we have in uninformed search? First one is breadth first search called as BFS. Uniform cost search, we call it as UCS. Depth first search, DFS. And depth limit search, DLS. And iterative deepening search, IDDFS. And then bidirectional search, BDS. So these are all the different types of search what we have in uninformed searching techniques. And when it comes to the informed searching techniques, we have a BFS here also. What is BFS? Is a best first search. Don't get confused with the breadth first search. It is a best first search, or we call it as greedy search. Greedy search. Okay. Then A star search and AO star search. We'll discuss each one of them in detail. Let's see what is uninformed search first. Searching algorithm have no additional information on the goal node other than one provided in the problem definition. We don't have any additional information of the goal node. That is called as uninformed search. Uninformed search is also called as blind search, that is already mentioned. This algorithm can only generate the successors and differentiate between the goal state and then the non-goal state. What it will say, you know, I have to reach one particular destination, I have to reach Vidhyaashram. So you know the goal. How to reach and what all the ways to reach, you don't know. That is uninformed. You know only the goal. What is my goal? I have to reach this particular college, right? So that is what the first definition sees, and it is used to differentiate the another college with Vidhyaashram college. That much it know. It will just differentiate, generate the successor to differentiate between which is my goal state and which is not my goal state, or it can be an intermediate state. Then the following uninformed search algorithms discussed in the further. So whatever the uninformed search algorithms we have seen in the last slide, that will be discussed one by one in further sessions. Next, coming to informed search algorithm. What do you mean by informed search algorithm? It contains array of the knowledge. What it has? It contains a array of the knowledge such as how far we are from the goal, what is the path cost, how much path it will cost, how much to reach the goal node. Same example or same scenario I can take. You left the home to reach the Vidhyaashram. In the previous example, you don't know what is the route you have to take, whether you have to go by bus, whether you have to go by two-wheeler, or whether you have to go by walk, because you don't know the distance, how much distance you have to travel. But in the informed search, what happens? You know all the information, right? You know how far it is from your home and how early you can reach if you go by walk, how early you can reach if you go by two-wheeler, or how early you can reach if you go by bus. So such type of information is provided, then we can use the informed search. This knowledge helps the agent to explore less, to search space and find the more efficient goal. At that time, what we have supposed to do, when you have a prior knowledge, we work on that knowledge and efficiently we can reach to the goal node. The informed search algorithms are more useful for the larger search space. Whenever the search space is very large, that time we are implementing the informed search algorithms. So informed search algorithm also called as heuristic search. As I mentioned earlier, it is also called as heuristic search. Heuristic means having some knowledge, that is called as heuristic. So it is having some prior knowledge, so we call it as heuristic search. What is heuristic function? How we are implementing the heuristic search? We are implementing the heuristic search with the help of heuristic function. What is heuristic function? Heuristic function which is used in the informed search and it finds the most promising path. Why we are using it? To find the most promising path. It takes the current state of the agent as the input and produces the estimation how close the agent is from the goal. It accesses the current situation and it compare with the knowledge whatever he has, and it will give the output that how far he is from the goal. For example, if you want to reach the Vidhyaashram, you have reached half of the way, you are nearby KSOU. So how far from KSOU to Vidhyaashram, that will be given with the heuristic function. We always represent a heuristic function with f of h, or I can say h of a node n. Node, what is n? N is a current node. What is h? H is a heuristic function for this particular node. That is a current node. How far this current node is from the goal node, that is given by the heuristic function. In the heuristic function, each algorithm, how it's going to work in the search algorithm, each algorithm how it's going to work means a problem graph containing the stat node and the goal containing the G node. What you have to have? One stat node you have to have and one goal node or the destination node you should have. A strategy describing the manner in which the graph will be traversed to get G. You have to have one strategy, one plan of action you have to have. How I am reaching from S to G, how we are reaching, that you should have for every algorithm. The fringe, which is a data structure used to store all the possible states that you can go from current states. I directly cannot reach from start state to goal state. In between I have a different nodes A, B, C, D, E and G. Like this I have different states. These different states have to be stored in the memory as we are tracking the path of the action. So that will be stored in one data type called as fringe. A tree that results while traversing a goal node. Whenever the graph is given, when traversing the goal node, we convert that graph into the tree to find the optimal result. A solution plan. What should be the solution plan? Which is a sequence of the node from S to G. How I can reach to the G? I can reach from S to A to D and D to G. That is one way. Or I can reach from S to B, B to E, E to G. That is one more way. I can use to S to B, B to C, C to D and C to G again. So there are different ways we can reach the possible solution. So we should have a solution plan with the sequence of action to reach the goal. So this is all about the heuristic function or the searching algorithm, how it's going to work. First you should have one stat node and one goal node. For reaching from stat node to goal node, you should have one strategy how to reach from S to G, and you should store all the intermediate transition or the visit of the intermediate nodes in the one particular data called as fringe, and you should convert this given graph into the tree so that if necessary we can do the backtracking and traversing the goal node, and you should have a solution plan, how to implement, which solution to be implemented. There are multiple solutions, which solution to be implemented. That solution should be on a sequence of a node from S to G, that is from starting point to the goal point. So coming into the difference between whatever we have from uninformed search to the informed search. In uninformed search, search without the information. As the name itself indicates, we are searching without any information. Here we have some array of information, searching with the information called as heuristic. Those information or the knowledge is called as heuristic. We don't have any prior knowledge, use the knowledge to find the steps of solution. Whatever the steps we need to find the solution, that will be taken care. The steps will be taken based on the knowledge what it has. It is very time consuming. Uniform search is very time consuming, as I don't know the perfect path. I don't have the information to reach the goal. When it comes to the informed search, it is very quick, because I already have fewer information or required information to reach the goal state. We can reach the goal very quickly. More complexity, we have more complexity. Here we have a less complexity. Example for uniform search, uninformed search is depth first search and breadth first search. Examples for informed search as A star algorithm, AO star algorithm, and heuristic BFS, that is best first search, and etc. These are all some of the difference what we can go through with uninformed search and informed search. That's all for this session. Thank you.